Okay, so let's get started on 7.7. What we're going to be talking in this section, is something called complex fractions. Now, complex doesn't necessarily mean hard fractions. What it means is fractions within fractions. That's what makes it complex. It's going to look, trust me, it's going to look complex, all right? But if you follow this one thing, it's not going to be that bad. So 7.7, we're talking about complex fractions. Let me give you an example about what a complex fraction looks like. Not so bad, right? Not so bad, just a regular old rational expression, that's a fraction. And then what we do is we go, okay, let's make something like that. Now all of a sudden it looks really nasty, right? Because we have fractions within fractions. And that's not such a great thing because we go, how in the world are we supposed to do this? Now if you were to explain this to me, which would you say would be the main fraction bar? The main fraction bar, is that this one?
No.
This one?
No.
This one? That's the main fraction bar right there. That's the main thing going across. What we have is one fraction over another fraction. So this thing, call our main fraction bar. So we have a numerator that's a fraction and the denominator that's a fraction. So our main numerator and our main denominator. You'll notice we have some minor numerators and minor denominators also, one for each fraction that we have. Now here's the whole idea. So I'm going to give you another example. We're going to build up to this one. Here's the idea and our steps. Firstly, can you identify what is my main numerator in this case? The main numerator, yeah.
3x over 25.
Great, this whole thing, that's my main numerator, that's my main denominator, that's my main fraction bar. Are you guys all with me on this? Just the terminology of getting to know these complex fractions? All right. The first step, what you're going to do, is you're going to make sure that your main numerator and your main denominator are just one fraction. Okay, just one fraction, not a fraction plus a fraction, or fraction plus a number. That you have one fraction on your main numerator and one fraction on your main denominator. Do I have that here? Is
No.
this just one fraction on the top?
No. Oh.
Just on the top right now. Yeah, that's just one fraction. Is this just one fraction? Okay, that's my step one's completed then, so I'll write that out. But what we're trying to do is simplify that the numerator and denominator have only one fraction. Okay, so we've done that already. This already has just one fraction, one fraction. Let's look up here. Look at the top here, folks, everybody. This is still just one fraction. Do you see that? Even though it has two terms in the denominator, the minor denominator, and this has two terms right here, this is still just one fraction over one fraction. This would also satisfy step one. Are you with me on this? How it wouldn't satisfy step one is if you had like plus something or minus something over here. Then that would not be one fraction over one fraction. Are you clear on that? Okay, so step one, not so bad, just make sure we have one fraction over one fraction. Here's the whole deal. What operation does a fraction signify? Addition, subtraction?
Division.
It's division, that's right. So what we know about fractions is that if we have a fraction, even a complex fraction, this means division, sure, and this means division, but mainly, this one right here, our main fraction bar, that also stands for division. Are you with me on this? So the main fraction bar stands for division. Likewise, I want you to think about this. If this is 3x over 25y squared over 9x squared over 5y, what this really means is 3x over 25y squared, what's this mean again? Divided by that fraction. So what we can do, we can set up a division problem. So if we have a complex fraction, all it really is, it's a fancy way to say that you have a division problem. That's it. Just a fancy way to say that. So step 2 is probably the only step I'm going to teach you today, because everything else we're going to be using past stuff for. Step 2 is set up a division problem. Let's try that. So we notice we have one fraction over one fraction. And this main fraction bar means division. And so what this says is instead of 3x over 25y squared over this, I'm going to write 3x over 25y squared. That's great. That's my main numerator. This fraction bar means division. So watch. We even say the same way. Divided by. We'd say 3x over 25y squared divided by what? Great, we're not flipping that around or anything. We have 3x over 25y squared divided by 9x squared over 5y. Here we have 3x over 25y squared divided by 9x squared over 5y. It's even read the same way. We have the same thing here. This is main numerator divided by main denominator. This is main numerator divided by main denominator. It says exactly the same thing mathematically. How many people understood that? Cool. Now, this looks a whole lot better than that, doesn't it? Why?
Because we're already used to do that.
Yeah, you're used to it, right? So we've already done that, and that's the whole point. You can't really work with this that much. You have to translate it into something that you know how to work with. Do you know how to divide fractions? Of course you do. Do you flip the first one, the second one, or both of them?
Second one.
Second one. So we're back now to section 7 point, what is that, 7.2 or something? 7.3, where we actually multiplied and divided fractions. We've done that in here, right? We're back to that stuff. So now step 3 is you're just going to solve this like you normally would. Or simplify, I suppose would be the better word. Simplify as usual. So if you remember this, what we did with division, we flipped the second fraction, which you already told me about. Instead of division, we have now multiplication. So we reciprocate that second fraction, and what do we do after that, folks? Do what now? Before that? Yep. We know how to multiply, right? We just do this. We put the dot dot. And then we simplify whatever we can. Do you see anything that simplifies, folks? Wake it up today. Let's get going.
5.
Okay. 5/25. Great. I heard that one. Someone else left-hand side of the room.
Y squared.
Y squared. Okay, got it. Someone else who hasn't spoken yet.
The 3 and the 9.
3 and the 9. And lastly?
The X.
What's on our numerator?
1.
Good. So we're not just going to write 15xy, right? That wouldn't be correct. We do have a 1 on the numerator. Over, now we can do that. We do a 3 times 5 is 15xy. And that's a very nice way to simplify a very complex looking fraction into something that's not that bad at all. Much easier to work with. Were you okay with that? Nod your head if you're okay with that one. All right. Not so bad, right? Not so bad. Okay. Remember, we're just going to start building up these things. They're not going to be any harder. It's the same process. It's just using stuff you've used in the past. Honestly, the only thing I'm teaching you today, the only new thing, is that. That's it. Everything else you'll have used already in this class. That's kind of nice, right?
Yeah.
It's almost like this math stuff builds on itself. It's weird, right? It's strange. Okay, so let's give this one a try. First thing, do we have one fraction over one fraction? Yeah, we do. Yeah, that's exactly right. It looks like this one, right? Not too much that's going on differently than that. We have one fraction over one fraction. Our main fraction bar is, of course, the middle one. We're saying this is our main numerator, that's our main denominator. We have one fraction over one fraction, which is what we need in this complex fraction. The next thing is to do what with this? Before we simplify, well, we are simplifying, that's right, that's what this process is, but how do we do that? We have it like this form, we want it like this. So we're going to set up a division problem on that. When you have one fraction over one fraction, that is your next step. So let's go ahead and do that. So we're going to show that step, that we understand that a complex fraction really means division. So I'd like to see that step. That's also going to make sure that you're flipping things correctly, that you don't forget to reciprocate, or that you don't accidentally reciprocate twice. If you do it in your head and then do it again, I don't want that to happen. So we're going to show that step just to make sure that we understand what's going on here. Got it? Right. Now that we have this division problem, we go, oh yeah, how do we do division? So we do that. So the 6x over x minus 5, that stays the same. The division, though, that changes to multiplication. And the second fraction we get is x plus 5 over 12. Now that's something we've dealt with for a long time now. How do you do that one? Yep, and before we're going to simplify things out, what are we going to do? Also, there's one more thing that we need on this problem. What do we need? Yeah, we definitely do. If we're multiplying, we better show that there's parentheses around those things. Now, I certainly don't want to distribute. I want to simplify stuff. That's the whole goal, right? Is simplifying things. How about the x minus 5x plus 5? Does that simplify? No, it's not the same thing. What does simplify?
64.
So 6 is gone. That becomes a 1. 12 becomes a 2. We'll write this a little bit prettier. We'll beautify it a little bit. What do we have on the numerator? X, that's it?
No, x times
If you just put x plus 5, you're forgetting something. What are you forgetting?
x.
Okay, we need that. And what else?
2.
Yeah, we generally write the 2 first. X minus 5. Nothing else simplifies. Don't distribute it. You're done. That's as far as you can go. Do you feel okay with this type of problem? So when you have one fraction over one fraction already, it's not so bad. We just take it, write division problem, reciprocate the second fraction, and we go for it. It's simplification. It's basic simplification. Well, that begs the question, why do we even have that step if it's always one fraction over one fraction? The answer is, well, it's not always given to you as one fraction over one fraction. Sometimes you're going to get something like the next example I'm going to show you. Right there, it looks so far so good, right? I mean, you could certainly do this problem. That's division. You'd set up the division problem because you'd have one fraction over one fraction. Are you following that? Very similar to the one that I just erased over here. Very similar to that one. You have one fraction over one fraction. But then as soon as I do something like this, we go, oh man, dang it. Why dang it?
It's not one fraction.
Yeah. It's not that. Darn. I can't do this whole process because if you look at that, how would I set up a division problem? Well, you have parentheses, right? But then you can't reciprocate, and that's the whole problem. Is that if you can't reciprocate, you can't do division. Are you following that? So in order to actually do the division, in order to reciprocate, you have to have one fraction so that you can flip it. You can't flip both of those. It doesn't work that way. So we have to make one fraction out of this. But fortunately, I want you to look at this problem. I would like you to ignore that part of it. Have you done problems like that before in this class? Yeah, absolutely. Can you find a common denominator for that?
Yes.
Sure, it's just y squared. Can you make that one fraction? Hey, look at that. That's exactly what we did in 7.4. The homework you turned in before this one is you took and you subtracted fractions, right? If you ignore this one, can you do the same thing there? Sure. You find the LCD, you make one fraction. So essentially, this is 3 problems in one. What this is subtraction, subtraction, and then you have division. That's all it is. So honestly, all I was teaching you today is that, because you've done this before and you've done that before. You just have to remember how to do it. So while these problems do have a lot of steps, you've done all the steps before. So let's go ahead and let's do this, because I need to show you one more problem after this, one more type of problem. Let's work on the numerator, and let's kind of ignore the denominator for right now. We're going to treat this like its own problem. I think someone already told me the LCD for this, but what is the LCD for this problem again? Great. We should be pretty much pros at finding the LCD right now, right? Should be pretty good at that. Do I need to multiply this by anything? This one? What do I need to multiply that by? Yeah, y over y. Notice that we don't have an equation. Do you notice that we don't have an equation? That means we can't get rid of denominators. All we can do is find a common denominator. That's all we can do. Do you see the difference? It's not like the homework you turned in, right? Homework you turned in, you could just get rid of denominators. You had the equation. That was awesome. Here you can't. Here you go, okay, the only thing I can do is find a common denominator and make that one fraction. But that's what we want to do anyway, right? Just make one fraction out of it. Folks, are you with me on this stuff? Are you waking up today to get this? I know it's early. That's Friday. But are you with it? Okay. So let's go ahead and keep going on the numerator. On the numerator, we didn't change the first fraction. Minus, what's the second fraction, please? Okay. On the denominator, I want a little bit more participation from you. Firstly, on the denominator, we're going to ignore this for just a second because this is how we want it, right? Actually, you know what? Maybe we'll keep going on this one just to get it one fraction. So next step. Do you have enough on this to make it one fraction? Yes. Yeah, I've got the y squared on both denominators. That's what I wanted. What's on the numerator, folks? Good. Don't put negative xy. We're not multiplying there, right? We're subtracting. So x minus y. That's perfect. That's what we want. We have now one fraction on the numerator. Follow? That's great. We're going to leave that alone for now. Now the denominator. Let's go ahead and let's do this together again. I want a little bit more participation from you. So can you tell me what is the LCD for the denominator? Great. Do I need to multiply this fraction?
No.
Do I need to multiply this fraction?
Yes.
By what?
X.
Good, because, yeah, not just x, right? That's not going to work. I'm glad you said x over x. Not just x, because we can't just eliminate denominators here. Why can't we eliminate denominators here? Good, only when you have that equals can you do that. So yeah, we're x over x. We're trying to find a common denominator. This is the 7.4 stuff, not the 7.5 stuff. This is adding, subtracting rational expressions, not solving with equations. That's the difference. So here we have the y over y squared. We have minus. We're going to get, what was that?
X squared.
Perfect. X over x squared.
The first one. Y over x squared.
I meant that. I would have found it eventually. On the next step. So now that we have the common denominator, we're great. We're going to do the y minus x over x squared. Would you raise your hand and feel okay getting that far? Good, I hope so, because that was all old stuff, right? We've done nothing new there. That was just adding or subtracting rational expressions. Now that we have this, can you verify that we have one fraction over one fraction?
Yes.
Sure. Now it's time to do step 2. Now it's time to make that division problem. So what we're going to do, we're going to write this out and have x minus y over y squared divided by y minus x over x squared. Still so far so good? Should be almost home free from now, or from now on. So we have the division problem. What are we going to do now? So let's reciprocate that thing. we're almost done. We're going to extend our line. Maybe put some parentheses here. Oh, does anything simplify?
Yep. The y minus x.
Mm.
Take a minute.
How about the x squared and the y squared? Do those simplify?
No.
But if you're looking carefully, do you see that this is x minus y and this is y minus x? Same exact values, the signs are different. When that happens to you, when that happens, we've had that before, right? Factor out a negative. It doesn't matter where, but factor out a negative somewhere. Because if you have that positive x, and this is a minus x, and it's a minus y, and it's a positive y, if I factor out a negative from one of them, I'm going to have a negative out front, but I'm going to have exactly the same thing. Are you with me? So I'm going to choose to factor out a negative from this one, just because I like x's positive. I don't know, I'm that kind of guy. So we're going to say that this is x minus y times x squared. Y squared. I'm going to factor a negative out of this thing. Now watch, please watch carefully where I'm going to put this negative. It doesn't matter where I put it. It doesn't matter. So I'm going to factor the negative up from here. I'm going to put it out front. No problem. Is that possible? Sure, you're factoring out a negative 1 and you're multiplying it, right? It doesn't matter where it goes. So I'm going to put that negative 1 out front. So when you ask me later, Mr. Leonard, where did that negative 1 come from? I'm factoring negative 1 from here. I'm just happen to put it out front. So what we're going to get in here is, it's actually going to be x minus y. I'll do one extra step so you can see it. Negative y plus x. Notice that negative 1 will change both those signs. I'm factoring that out. Are you with this so far? If you can't really see it, ignore the y squared and that looks perfect, doesn't it? I just have the y squared in the middle of it. It's not a big deal though. The negative can go anywhere I want it to. And then I'm going to reverse the order on these things. So instead of negative y plus x, I'll have x minus y. Now do you see something we can simplify out?
X minus y.
That's great. That's what we wanted to have happen. So this is gone. I get x squared over y squared. But what am I missing here?
Negative 1.
It's got to be a negative. Again, listen, it doesn't matter where the negative goes. Okay, the negative was on the bottom. The negative is actually from here, right? We factored the negative out. I put it out front, but it could easily go, I want you to look carefully, it could go here, that's not a problem. It could go here, that would be the same thing, or it could go here. Any one of those three spots. It does not matter where that negative finally ends up. Doesn't matter. Most people put it out front, because they say, I want to make the whole thing negative. That's the idea. Okay, the only time it would matter is if you had more than one term, then you'd have to distribute across it. Here, it doesn't matter at all. How many will feel okay with that problem? Good, all right. Are you ready to try the last type of problem we have to accomplish in this chapter? You ready? Hope so. I'm going to have to erase this. Are there any questions? No problem. No problem. Problem. Oh. Mr. Leonard, no, why are you ruining this perfectly good problem? It was so nice. You made it so ugly. Oh, negative exponents? Really? Really? But you know what? If you do one little thing, it's literally identical to the last thing we did. Identical to the last thing we did. There's just one thing I have to show you. So I guess maybe this is the second thing I have to teach you today. But it's still review from a previous class, so don't worry. It's what to do with negative exponents. I need you to understand something about negative exponents. can't always rewrite them to become positive exponents. The thing that you deal with is a fraction to do that though. So if you have x to the negative 1, that's equivalent, mathematically, that's equivalent to, instead of x to the negative 1, 1 over x to the first. That's a true statement. You can change the sign of your exponent, not the sign of the x. This sign out front does not change. The sign of the exponent changes. You can change the sign of an exponent by moving it from a numerator to a denominator, or a denominator to a numerator. You just switch the spot. I want you to notice something. Notice that right now, x to the negative 1 is on a numerator. Do you see it? Because I could put it over 1, right? It's on a numerator. It could be over 1. To change that negative exponent, I go, oh, I'm just going to change it from the top to the bottom, from the numerator to denominator. That changes the value of the exponent. Let me be very clear. Changes the value of the exponent, not the value of the term. Okay, that doesn't change. It's still positive x. This is still positive x to the negative first power. That is not a sign thing. That's an exponent thing. Now we need to try a couple more examples for you to really get this, okay? Let's try x to the negative 3. Can you rewrite that to make the x positive? What's going to be on the numerator of our fraction?
1.
Denominator?
X is
That's right. So we just change the sign by moving to the denominator of a fraction. A couple more I need you to see. This is a big one. This is a big one for you. I hope you're watching this right now. You only move things that actually have an exponent. So right now, is the exponent being applied to the 4? No, it's 4 times y to the negative 1. Use your order of operations. The exponent's just going to the y. So when I write this problem, is the 4 going to move down or is the 4 going to stay on the top?
Stay on the top.
It definitely is. This is going to be 4 over what? Y to the first. I don't write y to the first. I don't write the 1 there. I don't need the 1 here. I just wrote it so you can kind of see it. But you don't write the 1. Still okay? Yes, no?
Yes.
You sure? Okay. This is another good one for us. First question, is the exponent going to the negative 3?
No.
So is the negative 3 going to move to the bottom? Is the negative 3 going to change signs? Should it become positive 3? No. The exponent has nothing to do with the sign of the number. Nothing at all. So when you write this one out, you're going to go, oh, okay, what am I going to have on the numerator? Over what? That's how you change from positive to negative exponents, or negative to positive exponents in this case. You just move them from a numerator to a denominator. How many will feel okay with that? Okay, try a couple on your own just to make sure that you get this, all right? First one is what, please? Good. Second one is what? Perfect. Yeah, the 5 stays on the numerator over x. Just to the first, we don't write to the first, we just write x. Last one is what?
negative 7.
Good. That doesn't change. Only the exponents are the things that we're changing by doing this, not the signs of the terms themselves. How many people understood how we're doing that? Good. All right. So let's apply what we just learned to this thing. Can we get rid of negative exponents? We're just going to do it term by term. So let's all look at this together. What does 2x to the negative 1 become, please? Perfect. Yeah, that's exactly what we did over there. Then we have this plus sign. How about 3y to the negative 1? Awesome. All over, what's this one? That one. Then a minus sign, and then what's the last one, folks? 2. That's it. We just apply what we just learned to each term on that. Are you guys okay getting from the first expression to the second? Does the second expression look familiar to you? So we just did it. Just did that. We find an LCD. Use the LCD to combine our fractions. Have one fraction, then divide. Let's see if we can do that together. So here, we're going to go quickly through this stuff because we have one more example, and then I'd like to talk about a word problem. So we're going to move fast. But that's not a problem because we've done all this stuff before. I mean, this is old news now. LCD on the numerator.
X, Y.
X, Y.
Great, perfect. LCD on the denominator. That makes it easy. What do I need to multiply this one by? Just x?
X over X.
This one?
Y over Y.
Okay. So for our numerator, we're going to have 2y over xy. Notice it doesn't matter how I put the xy, I can put yx or xy. Plus 3x over xy. Are you still so far so good on this? You sure? Okay. Over, we have our LCD, we have that now in all spots, that's great. Over, again we're going to multiply this one by y over y and this one by x over x. We'll get y over xy. We'll get 2x over xy. Raise your hand if you're still with me. Feel okay about that? Good, I'm glad. That's just using the old stuff, right? We're just adding and subtracting these rational expressions now. It just happens to be within a main numerator and main denominator. So we keep on going. Do we have enough to make one fraction over one fraction, ladies and gentlemen?
Yes.
Perfect. So let's do that. The one thing I can't have you do, don't forget anything, don't lose any signs. Specifically down here, for some reason, I don't know why this happens, but for some reason people lose stuff. They lose stuff. They'll have like, instead of y minus 2x, they'll have 2xy. I don't know why. I don't know why, but that happens a lot. So I want to make sure you guys see that. Don't lose anything. When you're making the one fraction, I hope you're listening right now. When you're making the one fraction, literally all you have to do, write the denominator, write this numerator, write whatever that sign is, and then write that numerator. So 2y, then the plus, then 3x. That's all you got to do. If you can put them together and combine like terms later, then do it. Here you can't though, you have x's and y's, that doesn't work. On the denominator, we have the same situation. We have the x, y on the denominator. We have y, we have whatever the sign is, happens to be a minus, and we have 2x. That's how you make one fraction over one fraction. It's important that we get it that way. We don't have to change anything. You just write whatever you have as one fraction. That's the whole process. You still with me? Okay. What's the next step? So division problem, that's great. And we all know how to do division. We're going to reciprocate the second fraction and simplify it. Okay, last thing, what do we do? Okay, so extend. Put some parentheses because we're multiplying factors times larger factors, you know, those parentheses there. And then we get to simplify. Do you see anything that will simplify? That's great. Those are gone. Can I simplify anything else? That's not factorable, that's not factorable, that's our answer. So we're going to write 2y plus 3x over y minus 2x, and we're done. How many people feel okay with this type of problem? Good. Would you like to try one on your own? Okay. What I want you to do, we have enough time to make it through. I want you to get to this step. Okay, I know you can do it from the rest of there. I want you to at least get to that step. Remember to only move the single items that have exponents. Okay, that's the only thing you're moving. So in this problem, are you going to move the 2?
No.
Are you going to move the x?
No.
No. Are you going to move the y?
Yes.
Are you going to move this x?
Yes.
Yeah, that's got a negative and that y. I'm going to give you about 15 seconds to do the very first step, and I will make sure you got it right, so I'll pause you after that. Okay, let's see if you have this thing. When I'm looking at the problem, I see x to the negative 1. Hopefully you wrote 1 over x. Did you write that? Okay, we just talked about the next one, but just to be clear, you're only moving the items that have negative exponents. So the 2 and the x, they don't. They're going to stay on the numerator that they're on right now. So that's it. Over y. That negative exponent has to move to a denominator. Did you get that one? Awesome. This one, x to the negative 2nd. How are you going to write that?
1 over x.
Perfect. Then we have the minus sign. The next one, for some reason, seems to be a little tougher. It's got 2 of them, though, but they both move. So if they both move, what's on the numerator? 1. Just 1. Yeah, why? Well, because it's the same as this and the same as this. It's only you have 2 of them, right? So if we move both those to the denominator, you have to have 1 still on the numerator. So here you're going to have 1 over x squared y. So far, so good? Okay. So move quickly through the rest of it because we've done it before. LCD for the top, ladies and gentlemen. What do you have?
XY.
We'll multiply this by x over x. We'll multiply this by y over y. So far, so good? What do you have LCD for the denominator?
X squared y.
Good, because this x squared is already included. That's great. I don't need to multiply this one by anything. I multiply this one by what?
Y.
Okay, let's keep going. On the numerator, I've got y over xy. You still with me on this, ladies and gentlemen? I know we're going a little quicker than normal, but we have done this stuff several times now. Are you okay on getting the y over xy? What's the next fraction that I get?
2x squared over x.
Oh, it's looking good already. We have the same thing. On the denominator, how much do I get, please? Quickly.
Y over x squared.
Minus, and we didn't change that at all. We have enough to make one fraction out of one fraction. Here's what I want to make sure that you don't do, especially here. Make sure that on this numerator, when you write that, sure you're going to have x squared y. That's not a problem. Everyone's going to get that right. Don't forget about that minus 1. You can't just put y, right? You can't just put y. You can't just put 0 because, I mean, you're not subtracting here. You're putting y minus 1. That's what you put. And just leave it. You cannot combine those. That's what you have. Are you with me on that? That's it. On the numerator, you'll have xy, and you'll have y plus 2x squared. Exactly what you have here. It's not like you're doing any math on this case. You're just making one fraction out of it. You're just writing exactly spot for spot what you had. From here on out, you have your division problem. We would set up division. We'd reciprocate the second fraction, and you would simplify. Are you starting to see the things you're going to be able to simplify in this case? I mean, when you do this, you're going to simplify the y and the y, 1x with x squared. That's what you're going to have out of this. Work on this on your own, but your answer is going to be, let's see if I can do that. Where's that x go on the numerator? Did anyone make it down that far and get the same thing? Good for you. Okay. That's your final answer. I want you to see if you can figure out how to get from here to here on your own later on, okay? Same idea. How many people feel pretty good about what we just talked about? It takes care of our 7.7. Now, I would like to talk about one more word problem to give you a little bit of help on your homework.